Welcome back. Today we're going to be doing Leetcode question 897, increasing order search tree, which is a Leetcode easy question. So we're just going to go through one possible solution. So it says, given the root of a binary search tree, rearrange the tree in order so that the leftmost node in the tree is now the root of the tree, and every other node has no left child and only one right child. So for those who don't know what in order traversal is, it's basically traveling or traversing to the left node first, and then the center, and then the right. So what this does, like in a binary search tree, is that it basically gives you all the numbers in sorted order, in ascending order, definitely, because you're going to the left first, which has the smaller numbers, and then doing the one that is in the center, which is going to be less than the one in the right. So you can see a diagram here that illustrates how the tree is going to look, after you do the processing. So the idea that we're going to be using today is basically taking all the numbers in the left tree and then feeding them into a vector. And then after that, we're just basically going to make another tree, which we are going to return as the result. So in this case, we need two things, right? We need the node that we're going, like the root that we're going to return as the result. And then we also need the vector that we are going to push the numbers to. So let's just declare those two variables. So tree node root, let's call it result root node, and then we need the vector of integers which we are going to push the numbers to. So let's just call it numbers. But one thing that you have to check for before you do all of this is that there is a case where this root that you are given might not have anything, might be equal to now. So you want to check for that before you do any processing so that you don't waste your time. So you're just going to check, like, if the root is equal to now, just return it because it's equal to now anyway, or you can return now if you want explicitly. So return root. And then now what we are going to do is, since we want to get all the numbers that are in this node, right, in this tree, and then feed them to the numbers vector, we can make a separate method that is going to do that for us, so that we kind of separate our concerns. So what we'll do is we'll make another method here. We'll call it it's a void method. Let's call it traverse tree, and get numbers. Right, it's going to take in the root node and take in the vector that we are going to populate by reference to save memory. And we say vector, let's just call it nums in this case. And since we said that in order traversal is going to the left first, then the center, and then the right, we're going to do basically that, but feeding the numbers into the vector. But before we do that, because this is going to be using recursion, we want to also check if the node that we have at that particular point in time is not equal to now first, and then that is when we're going to process it. So we'll say if it's not equal to now, traverse, go to the left side. So you're going to go to root left, with the same vector, and then for the center node, you're just going to add it. So nums.push back, then you put in the value of that node, and then you're basically going to go to the right. So root right. So after doing this, you now have the numbers. So in this case, when we come back to our main function here, we're just going to go to say vector int numbers is equal to, and we call this method traverse and get numbers. Then we pass in the node that we have, the root, and then we pass in this same vector that we want to populate. This. And then after doing this, we have the numbers, right? What we now want to do is we want to make or populate our result here. So we're going to put in the first number so that we can just iterate easily using a for loop. So we're going to say result root is equal to new tree node, and then we make use of this first constructor here that takes in a number, right? So new tree node, and then we use the numbers. In this function we're calling the vector numbers, so numbers at position 0, right? And then we use a temporary variable to basically iterate or a cursor. So we say tree node cursor is equal to result root, right? Right. And then we now say for int I is equal to 1. So we're starting from 1 because we've already gotten the first number. Now we're just going through all the rest of the numbers and just giving this cursor here a right child. So for int I is equal to 1 and I is less than the size of the array or of the vector, numbers dot size, then I plus plus. Then we're going to say cursor is equal to new tree node so in this case, actually, let's see, here the cursor is equal to the right, but this constructor here initializes the right as a null pointer, so we actually don't want to do that. Let's just take the result root by itself like this, and then in here what we'll do is we'll say cursor right is equal to new tree node, then we'll pass in the number at that particular point, which is numbers I, like this. And then to iterate we'll just say cursor is equal to cursor right, like this. And then when the loop comes back again, it's just going to make another node to the right of it using the number at that particular point as well. And then after doing this loop here, we have all the numbers and as a tree with only right children. Then we just return the result root like this. So let's check if it works or if we made any mistakes. Okay, so it says no viable conversion from void to okay. Yes, this is a void function, so we're actually not returning anything, so we just need to call the function with the array. So we can just put a semicolon here and traverse, and everything will be populated. Now let's check again. Okay, so we have been accepted for the first test case. Let's submit and see if we pass all the cases. And well, you see, it works. So this is one solution that you can use to solve this problem. And of course, you can improve this solution like in many other ways. And if any of you has any suggestion for a better way to solve it, just let me know in the comments. But until then, see you in the next video.